Okay, so no problem. So in this we will first understand what is the linear regression. So linear regression means that you will have the one dependent variable and one independent variables. That is the basic requirement. You must have the data in the form of the dependent and independent variables. So for example, we already discussed that your number of hours, whatever you are spending, that's impacting your achievement. So you will get the 80%, 40% like that. And how much it is impacting your dependent variable. So achievement of the marks or percentage of the marks is your dependent variable, and a number of hours you studying, that is your independent variable. So here you will see that one explanatory variable is there, that is your predictors. So is one variable is enough for the predicting? So initially you have some assumption, you will have some objective. Based on that, you would like to go for the simple regression only. So in that case, you can go for single regression. After that, you feel that it cannot be one variable which can be impacting your dependent variable. So maybe how much you time spend in your classrooms, okay, how much you interacting with your friend on the subject matters. So this is the another variable which is impacting your achievement of the marks. Okay, so this is there we will use to try to use this multiple linear regression. So in case of this multiple linear regression, so one explanatory variable, that is our predictor variable. So for an example, how good a student in playing the basketball, so how much hours of the practice he doing, is the one variable is enough for the predicting. So really you cannot say that one variable is directly impacting in that case. So you will thought of hours of the spending, then physical fitness, awareness, confidence, team, and the height will be the example of this case. In the real problem, what is very complicated, but luckily you will have the regression analysis. You can understand the various upcoming problems. Okay, so how your student behave, you can create your models. Okay, so how your data is feeling or giving the output. So that's you can do it with the help of the regression. So for better understanding, we use the multiple linear regressions, allow the users to account for the multiple explanatory variables, and therefore to create the model that predict this specific outcome being researched. In multiple linear regression work in a very similar way to the simple linear regression. So whatever you doing in linear regressions, that's things you need to do in multiple regression as well. Okay, so another example which I will be trying to show you, that do you know the birth weight of the any children or any newborn baby is impacted by the mother weight. Okay, so doctor suggests that if it whatever the mother weight is there, that is definitely impacting the newborn baby weight. Okay, so this is a newborn baby weight is the your dependent variable, and the mother weight is the your independent variable. So how much that mother weight is impacting the newborn baby weight. So this is the your linear regressions. And again, doctor suggests that not even mother weight, but father weight is also impacting the your newborn baby weight. So if we can use the two data, that is the mother weight and the father weights, and that would be impacting your newborn baby weight. So in that case, we will going for the multiple linear regression. So example of the multiple linear regression in education, you might be have higher education attainment, and then the predictive variables are social class, family composition, maternal education qualification, student attitude, university and parent education, aspiration for the students, etc. would be your more valuable. If you are economist or you are studying the economics or management, then you will you would like to see that what is the country rate of male literacy. So what is the male literacy rate that is impacted by the smaller rate of the annual population increase, greater domestic GDP, and large percentage of the peoples living in the cities. So these variable is impacting the rate of the male literacy. Okay, so in that case, you will go for the multiple linear regression. In case of the management, higher salary attainment will impacted by the types of the university, a percentage of the marks in the last degree, percentage of marks obtained in the 10th and 12th. So that's you will be creating the model. So basically, as you will see here, this is your dependent variable. So higher salary attainment. So I'm saying that as cell. So as cell is my dependent variables, and this alpha is nothing but it is your intercept. So how you will how much minimum value would required to to create your line. Okay, so that's is basically intercept, and beta 1 university, and beta 2 marks, and beta 3 is marks again for the 10th and 12th, and beta 5 is experiences. Okay, so this beta 1, beta 2, and beta 3 and beta 5 are the your intercepts, and basically alpha is nothing but it's a slope. So from where you can start your regression. Suppose that this is your x, this is your y-axis, and this is your x-axis, and it is started from the from where. So this is your let's say this is your x-axis, and this is your y-axis. So line can be go from this one. So this point is nothing but it is the your alpha. Okay, so this if we can just predict these values, and then definitely we can say that this is the our model in case of these 2 variable, 3 variable, and the 5 variables. Okay, so here you can generalize these equations. So we can have the y cap. So this is the your dependent variable, and then a is your slope, and beta 1 and beta 2 and beta k are the coefficients. So these are the coefficient, and this is the x1, x2, and xk are your independent variables. Okay, so you can take k independent variables in case of multiple regression, but your y should be your dependent variable. Okay, in this dependent variable, before that I can go ahead, you must know what is the data, what is your data types. So what do you understand by the data types? So in the data types, what kind of the data you will require in case of this one? So what kind of the data is required? So in case of the dependent variable, so dependent variable must be in the form of the ratio and an interval. It should be your continuous variable. So if it is your dependent variable is your continuous form data, or it is ratio interval data, or it is a quantitative variables. Okay, and then you will going to apply this regression techniques. Okay, so here we are discussing that if your dependent variable is 1 and you would like to apply the you can apply the only the interval data or ratio data or continuous data, then you can use this regression techniques. Okay, in this case here we will be showing you these are the my coefficients. So beta naught, beta 1, beta 2, and beta k are the my coefficients. Okay, and the x1, x2, and so on xk are the my independent variables, and this is your epsilon is your random error variables, and y is your dependent variable, and rest are your independent variables. So this is the equation which you will see that in the multiple regression. So some of you are saying that what is the types of the data? So maybe it's nominal, ordinal, interval, ratio. While you just planning to go for the any kind of the analysis, let's say you would like to go for the factor analysis, or you would like to go for the regression. If you want to go for logistic regression, then you think of what is your data type. So it is the nominal data, then you will go for the logistic, or something else is there, then you will go for the multiple regression. So you always think on that, whatever the question you are getting from the experiment or from the survey, from the secondary data, then you need to see that what is your dependent variable and what is the types of that dependent variables. It will help you to understand betterly about the your variables. Okay, and then after that you can decide that you will be going for the multiple regression, logistic regression, time count regression, so many others would be there. Okay, so you will go for the Cox regressions. Then you need to decide accordingly. Multiple regressions and visualization for the two independent variables. So it is something, if it is, you will see that your x-axis is there and y is there and the x2 is there. So in this case, you will be seeing that this is the y is equals to beta naught plus b1 x1 beta 2 x2. So here you will have the two independent variables, and here this is the scenario. In case of the one independent variable, so beta 1 x1, and this is your epsilon. In case of this one, so multiple linear regression model all allow for more than two or more than one independent variables. Okay, so that we were writing that y is equals to beta naught plus b1 x1 plus b2 x2 plus epsilon. Okay, so this is your and always next step is that whenever you going to apply the one sample t-test, or you will going to apply the pair t-test or regression, or you want to do anything, okay, if you want to go for the chi-square testing, then you need to check these some assumptions. So in case of the chi-square, you will be looking that the cell count should be greater than the more than or greater than or equals to 5. Okay, so this is the one of the assumption for chi-square. Similarly, here also you need to look up the assumptions. So always you need to test the assumption. Then after that you can decide on the second stage, you can decide about that method or statistical method is appropriate or not for your data. Okay, so in this case, multiple regression, we will be using the multiple linear regression, means similar to the similar linear regressions as you did in one sample t-test or two sample t-test. So whatever the assumption is there in one, and that you will follow in two sample t-test, and again in the analysis of variance. Some additional assumption would be there, but you will follow all rest of the which you did it in two sample t-test. Okay, so here also you will also talk about the simple linear regressions. That's assumption can be followed in the multiple linear regression. Now linear relationship is the outcome variable is roughly linear. Okay, so roughly linear or closely linear relationship with the each of the explanatory variables. Okay, so your outcome variable is there, and this your independent variables is there. So 1, 2, 3. So this is a linear relationship needs to be there. Next is the homoscedasticity. What is the homoscedasticity? Means check that the variance of the residual is constant at all levels of the predicted outcomes from the full models. That is the model is including all the explanatory variables, or the variable of the residual should be the same at each level of the explanatory variables. Okay, so and then independent error, this means that the residuals should be uncorrelated. Outliers, you can see the outlier in differential cases. So multicollinearity is there. So multicollinearity exists then when two or more than two explanatory variables is there. So suppose your mother weight is there, father weight is there. So there might be some kind of the multicollinearity can be exist. So that's you need to check. Okay, so are highly correlated, normally distributed residuals. Okay, so this you need to understand that about the regression, multiple regressions. So we will talk about the how you can judge, how you can identify, you can look up the multiple regression assumptions. So maybe again I'm going on the assumptions, so you can have a clear idea on the what is the homoscedasticity. So variance of the residual is constant. Okay, so whatever the error term is there, so if I will take the error, that should be a constant. So it should be the fixed numbers. Okay, and it cannot be vary. So that is the homoscedasticity. The plotting the residual against the value predicted by the regression model. So once you will do the predictions, then you will do a residuals and the predicted value. So if it is this is there, that this will show you that how you can identify the homoscedasticity. Then after that we will talk about the variance in all explanatory variables. So that can be done with the histogram for each. Then this assumption is rarely violated if you have created good measures of the variable you are interested in. Okay, independence error. So error should be independence, outlier, and that you can do with the help of the scatter plot. Multicollinearity means the correlation greater than the 0.8, then the problem is there. So variance inflation factor is there, and tolerance statistics is there. So based on that, you can decide that it is a multicollinearity exists or not between these variables. Normality distributed residuals means histogram of the residuals. So you can draw the histogram of the residuals. That will help you about these assumptions. So scatter plots showing the homoscedasticity. So assumption is not met. So if you will see that regression standardized predicted value and the regression standardized residuals. So homoscedasticity is not met in the scatter plot. That is the homoscedasticity means there is a same value would be there. If the assumption of the homoscedasticity is not met, it may be a possible that to transform the outcome variables. So whatever your dependent variable is with you, that you can go for the transformation method. So you can go for log, you can go for the exponential, like that. So you can go for the some of the transformation techniques. Okay. So in here in this pictures, you can also see that the data point seems fairly randomly distributed. Okay, with the fairly even spread of the residuals at all the predicted values. So this means showing that your assumption is met here. Now we will so comparing the various types of the multiple regressions. So you can have the some data sets that you can look up. So SPSS set up a simultaneous multiple regression on 3 predicted variables. So that's you can see in these pictures only. So you can enter the variable and remove. So first look on the table of the variable enters. So you will see that there are the 3 predicted variable have been included in the regression analysis, and you use the some methods. So that is your enter method, and this is your model summary for the multiple regressions. Suppose that this is your model, and this is your R value, this is your R square value, and adjusted R square is there, and this is the change in the statistics. Okay, so what would be the change in your statistics that will can be seen, and this is the analysis of variance table is there, so which will tell you that is your model, whatever the model you are running it, is that significant or not, that you can do it from the. So let me show you a more simpler way. That's we already did here. So in the regressions, you will have the predicted y and the function of the independent variables. So I already given you an example of the birth weight, and which is equals to 2.65, then plus multiply by the mother weights plus some coefficient value, and then father weight. So basically, I'm trying to say you from this example, you want to create some models. So for an example, so you want to predict the birth of new baby. Okay, so this model is created by the some based on the some data, or based on the some hospitals data. So I'm just highlighting this one. So this is the you created this model, and then whenever it can be used for the further analysis or further understanding that mother weight is how much mother weight is there and father weight is with you. Then you can easily predict that what would be the upcoming baby weight. Okay, so you can just put the value of the mother weight, and here in place of this one, and then replace the value of the father weight, and multiply by this 0.008 by the mother weight, and 0.004 by the father weight, and this will give you the birth weight of the newborn. So basically, you need to trying to make it some models, so that it can be it can be used in an industry, it can be used in the organizations. So so that's wants to you make it from here. Okay, so this is the, so here y is your dependent variable, response outcome, you can see different names, and x is the your independent regressors, predictor, explanatory, and the determinant. So here in this case, linears means you will use the only this much, that is the your predicted y value of y is equals to a plus bx, then predicted value of y in case of the many independent variables. So this is the x1, x2, so on xk. And here another example, you know that as you will going older, or as your age increases, then you will be seeing that is my slide is not moving. You can see I'm on 10th slide. Okay, let me see once again. Slideshow is not working here in my screen. Okay, so you can see again here. So linear regression means leads to a line and surface if two or more regressions. Okay, so it's just a thing is that this is the your x-axis and this is your y-axis. This is your x-axis and y-axis. Okay, so you can create the line. So in case of the linear regressions, okay, single linear regressions, if it is, you will have more than two independent variables, so it will create the surface. So it's like that something. Okay, so it will create the surface. So this is the difference between the single regression and multiple regression. So this is your predicted value of y and this is your predicted value of y when you will have x1 x2 so on, xk is the independent variable. So you know that as you will see that age is going to be increased, and that is also chance that you will get the blood pressure, diabetic, some kind of the disease you will occurred after the certain age. Okay, so you want to create some model. Okay, so here you will see that systematic blood pressure is going to be increased as age is going to be increased. So here we can create the some models. Then usually the systematic blood pressure is 110 plus 1/3 of their age in years. So you can just, whenever any patient is coming to your hospital, you just enter the age of the patients, and then after that you will see that what is the impact on the systematic blood pressure. Okay, that you can do here. Then predicted birth weight. So predicted birth weight can be also find out with the help of the 2.65 plus multiply mother weight and the father weight, which is already we discussed. So whenever you will have you have this model, and then accordingly you can go for the any kind of the predictions. Okay, so when, if it is anything is coming to your hospitals, and certainly you will put the mother and father weight, then you can able to find out the rest of the information. So the concept of the linear regressions, as in the previous slide also we talk about the, it should be a linear. Okay, so this linearity you can see in the each stage. In case of the non-linear regressions, so x have the square, cube, log, etc. So as we talk about the, it should be a linear. So if it is anything is coming other than the linear, for example, the square is there, cube is there, log is there, then in that case you cannot go for the linear regression or multiple regressions. Then you will try to go for the non-linear regression analysis. So predicted diastolic blood pressure for the female in mmHg. So this is the nothing but 58.18 plus 1.66 of the age. So in this case, you will see that what is the trend of the male and female. So the trend of the male is the linear relationship, but trend of the female is not a linear. It is a some curve is there. So here we cannot go for the regression analysis. So some more example of the non-linear regression. So if you will have such kind of the graph, then you cannot go for the linear and multiple regression. You will go for the non-linear regressions. Okay. So in this case, we already talked about the only one regression is there. Then you will see that you can just predict the between the two variables. If it is multiple, means more than one regression is there, then you will create the you can create this pair, and you can see that what is the linear relationship between these variables. So in the example of this one is we already discussed that. So this is the very important concept. So what is your intercept and what is your residuals? Okay, so intercept means that from where you can start this point. So this point is your intercept. So in the last example, we talked about the minimum weight of newborn baby. What would be the minimum weight? So this can be decided by the intercept value. Okay, so you will have a, let's say, sample data is with you, and then you can decide that what is your intercept value. Okay, in case of the systolic blood pressures, so this is the how much is would be your minimum blood pressures. So that is the 110 is there. So it is started from the 110. Suppose that 110 is lying here, then it would have started from the here. So this would be your linear line. Okay, so this is the A is the intercept and plus bx, and b is your slope, and y is equals to a plus bx plus e. E is your residuals. So this is the some more parameters which you can see that you can find out the value of a and b, means alpha and beta you can find out. So a is what y bar minus bx bar, and b is nothing but it is the sum of these values and sum of the square of these values. So this you can find out. So this is the your point estimate. So you want to find out these 2 points. So you just find out the 2 coefficients, which is the intercept and the your the coefficient value. Okay, so that's you need to find out. So then after that you can go for the interval estimate. Interval estimate means confidence interval for the beta, means whatever the coefficient is with you, that you can find out, and the coefficient interval for the alpha, that you can also find out from here. Then test of the hypothesis for the parameters. So beta is equals to beta naught can be done with this formula. So you cannot you can just see how you can understand the then in case of the alpha is not equals to alpha naught. So this is the formula for alpha testing and the beta testing. Confidence interval and the prediction interval for the predicted value of y can be find out the standard error, the estimated mean of yx is equals to these value, and this is the predicted individual value of yx. So you can also calculate the CI for y for each value of x. Now we will talk about the multiple regressions. We already so far talk about the multiple regressions, means more than one regression is there. So for example, mother weight, father weight. So these are the 2 regressions, 1 and 2. So this is impacting the newborn baby weight. So in multiple correlation coefficients, so multiple correlation between the observed value of y and the predicted value of y. R square, what is the R square? How you can do the interpretation? So R square is the percentage of the variance. Explain and extremely good indicators for the goodness of the fit. However, the valid only for the linear regression, but most important in biological education. Okay. So after this, that whatever is your dependent variable, whatever the dependent variable, so it could be your nominal, ordinal, interval, and ratio. Accordingly, you can choose your corresponding statistics. Okay, corresponding statistics means if it is your nominal dependent variable is your 2 label, means for example yes and no, present and absent, then you can go for the logistic regressions. If it is your dependent variable has 3 or more than 3 labels, then you can go for the multiple logistic regressions. Okay. Then ordinal, nominal, ordinal dependent variables. So your dependent variable in the form of the order. So in that case, you can go for the ordinal logistic regressions. Okay. So now we will come on the interval dependent variable. So for example, you will taking the A's and then then percentage of the marks, or you will be taking the systolic blood pressure as your dependent variable. So this is the interval data. In this case, you will go for the test of linearity. You will first check the linearity. Then if it is linearity assumption is met, then you will go for the other assumptions. Okay. So for example, you will go for the test for the independence of the independent variables and the homoscedasticity. If it is these assumption is met, then you can go for the linear regressions with one independent variable, or multiple regression with two independent or more than two independent variables. Okay. So suppose this assumption is not met, then there are various corrective measures can be taken, that you can go for the some corrective measures, and you can go back to check your data. If it is linearity is not met, suppose your linearity is not met, then what you will do? So in that case, you will go for the transformation is needed. You can do some kind of the transformations to change your scales. Okay, so that you can do with the help of this one transformations. So add interaction or higher order terms to your independent variable. So if it is your independent variable, test the normality again, same the procedures, test the normality, then independence, then homoscedasticity. If these met, then you can go for the multiple regression after the transformations. If it is not met, then again you need to go back the other methods. Suppose this is the non-linear transformations of your dependent variables, variable or independent variable, then you will again go for the normality, independence, and the homoscedasticity. If they are met, then you can go for the appropriate multiple regressions. Otherwise, you will not go. So basically, what I'm trying to say here is that if it is your dependent variable in the yes and no kind of or nominal data, or maybe a dichotomous, then you will go for the logistic regressions. If so, it's all depend on the what is the characteristics of your data of the dependent variables. Okay, that's you need to identify, then accordingly you will go for the corresponding things. So let me tell you once more for somebody is asking that. So what is the label of your data? So what is your types of the data of your dependent variable? So whatever your dependent variable is with you, that you need to check. So if it is suppose dichotomous, means yes, no, present, absent, male, females. In that case, if it is data exists with you, then you can go for the logistic regressions. If it is more than two labels in the nominal data, then you go for the multinomial logistic regressions. Okay. Similarly, if it is the ordinal dependent variable is there, then you will go for the ordinal logistic regression. For example, the mild, moderate, severe disease is there. Then you will go for the other logistic regressions. Okay. Ordinal logistic regressions. Then after that, if it is your interval data is with you. Interval data means age data is with you, BMI is with you, the systolic blood pressure, achievement of the marks is there. Okay, and how many money you spent on the educations. These are your interval data variables. So if it is that data is with you, then you will check one by one all the assumptions. So for example, your assumption is you will check the test for the linearity. So first you need to check the linearity of your data. Then you will go for the assumptions, another assumption. That is the test for normality, independence of the variables, and the homoscedasticity. Okay. So if these all are met, then you will go for the linear regression or multiple regressions. Okay. That's I'm trying to say. If it is this is not met, the linearity is not met, that means you need to do some kind of the transformations. Means take the log of your dependent variables and try to see that is that linearly associated or not. Okay, so this is the information which is I'm trying to replicate from this slide, that whatever the label of your data means, what is your data type of your dependent variable, accordingly you can decide the corresponding statistics. Okay, are you getting my point?
Sir,
Yes.
sir, can you please elaborate when we use the linear regressions and when we use the multiple regressions, and what kind of parameters should be there?
See, in this example, you can see so basically multiple regression means you will have more than one regression, more than one independent variable. Suppose you will have dependent variable, one dependent variable and one independent variable. For example, mother weight is impacting the baby weight. So this is the, you only taking the one variable, means one dependent variable, one independent variable. So
Yes,
this
sir.
means that you can use the single linear regression.
Yes, sir.
If it is, you will have mother weight as well as the father weight. So how many variables here, independent variable? Two, or it is more than two. Then in that case, you can go for the multiple regression. It's very simple.
Sir, can we proceed it with more than one dependent variables?
Yes, you can go for the more than one independent variable. You can take the 3, you can take the 4, you can take more as well.
No, sir, I am saying that can we take more than one dependent variables in that case?
Yeah, you, if it is, now this is the, we are talking for the this is the simple analysis. Okay, simple regression analysis. So if it is, you will take the y in place of the y, you can take the y1, y2, so on, yk. So means yk dependent variable, that is the multivariate analysis. Okay, that is your multivariate analysis. That
Okay.
you can also take.
It means I have multiple y's and multiple x for that.
You can take the multiple y's and multiple x. So that kind of the analysis is called the multivariate regression analysis.
And sir, can we predict the correlations between independent and dependent parameters through the regression result?
That you can do.
Okay, sir. And sir, last
Okay, so
question.
let me just elaborate to all of you. Then you can have a question, and you can ask for the question. So this is the one problem. Let me show you my data as well. So this is your practice data. So I'm trying to open this practice data. So already I sent you Excel file, so you can do an import in SPSS. So my data is here for you. So you can see that this is the data. Okay, so I shared the Excel file, so you can do the import by this way. You just go into the file, then import data, then Excel. Okay, so you will see some window will come up, and then give the path and the change the file name, and then after that you will able to see the data. Okay, so this you can do, and you will get this data. So you can able to see this data. So we will be trying to use this two variables. In the Excel, it is available. So you need to try to import this one. So how to do the import? Just go into the file, then import data, then Excel. So you need to change the file name, and then after that you can do it. So here in my questions, we will be using the academic ability and the parental education. So can anyone tell about that, how to ask the questions about the parental education? What are the ways you know? What are the ways you can ask the parental education? By the interview? No. What question you will ask for the parental educations? Questionnaire is a very broad thing. What question you will ask to know the parental education?
So, good evening, sir. So we can ask what is your highest education, highest degree?
Highest degree, okay. Education qualification degree have achieved?
Yes, sir.
No.
You can ask about years of completed years of education.
Yeah. So everyone is giving their options, that someone saying that we can ask the you educated, uneducated, UG, PG, like that. Okay. Somebody saying that a government college, private, like that. But we are interested to know that how many your data should be in the interval forms. So how you can ask the same question in the interval form? So you will ask the how many year you span in a education. So you spend 2 years means you just qualification up to the two level. Okay. If you spend 5 years means you just got the 5 class degree. Okay. Similarly, you can spend, so you just asking the how many year you spend. So this will tell you that what is your basically a parental education. So this will be, we will be trying to use here in my exercise. So this is the linear regression exercise. So we develop a linear regression equation to determine the relationship between the academic ability scores and the candidate university entrance test and then parental education. Okay. So we will have the parental educations. Then we will ask the what are the variables. So we will have the academic ability and the parental education in years. So this you can see in your data as well.
Excuse me, sir. So I have one doubt in this case. So suppose there is a candidate who has spent, say, has taken, say, 2 to 3 years to pass, say, grade 10. So that is not an added advantage. So that becomes a limitation. So he has years of education would probably increase, but his level of education may not be what we are looking at, sir.
Yeah, you are true, but let's we can discuss more on this part. Means is that how much is doable, but we are assuming that whatever we are asking that roughly they are spending in how many years, so that my data would be in the interval form, so that it can be used for more predictions things. Okay, so that's
Okay,
I'm trying to do.
Thank you, sir. So basically, we are looking at interval data, sir.
Right. Okay. No, the same information can be asked, and if you will go in the field, then
Yes.
how you can ask the age?
Yes, sir. Yes.
You can ask the age. Are you lying in 10 to 20 or 20 to 40 or 40 to 60, like this? You can ask this interval as well, but you can ask directly how many. What is your years?
Yes.
Till this point, how many years you old?
Yes, sir. Yes. Sir.
Okay?
Thank you, sir. Thank you,
So
sir.
you can ask the same question in a two different way. So if it is nominal ordinal can be less analyzable, or
Yes.
interval ratio is the more analyzable. So that's I'm trying to bring out this kind of the data. Okay. So
Yes, sir.
this
Thank
was
you.
the purpose. So we will be using these two variables, academic ability and the parental education. Now you can see that how you can
Thank
do.
you, sir. Thank you, sir.
This is your problem basically. So academic ability, this is the out of 100 score, and the parental education in years. And now I will trying to show you how you can do in SPSS. Okay, so you need to go for the analyze, then you will go for the regression, and then linear. Okay, so we will so far we only discussing on the linear part. So here you can go for the linear, either a single multiple regression, or single regression or multiple regression.
Excuse me, sir. Sir,
Yes.
the number of years which has been taken, it is actually counted, no? So it is showing in data view, it is showing nominal data. So will it be considered as nominal data, or
Okay, let me change,
quantitative data
because
will have to change it, no?
let me change this one. So this is my this one. Now it is fine.
Yeah, I mean, this is needed, now it need to be changed.
Yeah, it is needed. It is always needed, because once you will import your data, it will it is your job, or it is our job. That's we need to look up the measurement of your data. All
Thank
right.
you.
So this you can check, and then after that you will go for the analyze, then regression, then you will go for the linear. Okay. Till now everyone can reach. Then once we will click on this one, then from here you can go for the simple regression or multiple regression. So let me click here. So in this this new window is coming up, and here it will asking. So you can just view all this one. So it is asking your dependent variable and independent variables. Okay. So you can drag here your independent variable. If it is 1, then you can drag it. If it is 2, then you can drag it. This is your dependent variables, so that you can do here. And in this method, you can go for the enter method. That is the basic methods. You can go for the stepwise method, remove method, backward and forward method. So, okay. So these are the methods you can opt for further analysis while you will have multiple regressions. Okay. So here first we will talk about the here you can go for the case level weights. So this for this we will not go here. Let me see what are these statistics. So it will ask you the model fit. You can go for the R-square change, discrete statistics. Then you can go for the Darwin-Watson. So you can go for the Darwin-Watson as well. In the plots, here you can go for the histogram, normal probability plot. You can also go. And these are your X and Y variables. Okay, so that you can go. And here, this is your some more statistics which we will be requiring. Then we will go for the residual unstandardized, standardized values, so that we can find out. And this is the another options which you want to use it. So if you want to go for any format, so that you can use it this one. So these are the option is with you. Now I'm trying to use these two variables. So what is my dependent variable? That is the academic ability. So academic ability will go in dependent variable. Okay, so this is my dependent variable. Then I will go for the parental education. So this is going here, and I'm using the simple method and just running without any statistics, without any selections. I'm running this one. Okay, so now we will check all these things. So I run these regressions. You can also do here. So you can see that this is the, you use this model. So you can use the one model. and you are having the how many variables. It's saying that you are having the parental education. You use the enter method. So this is your dependent variable.
Sir, what does that A and A means? Like after above removed, it is A in the power.
Yeah, so here we use the enter method or some other methods. So it's just A means you will be using the dependent variables. So these are the list is there. All requested variable are entered. B means whatever your independent variable, so that you enter. A means your dependent variable. Okay. So then after that, you will go for the model summary. So model summary means you will get the R value, then you will get the R square value, adjusted R square value, and then standard error for the estimates. Okay. So here you can see that R square very important for your interpretation. So how much this parental education is impacting your academic ability. Okay, so this is impacted by the 52%, 52.9% is impacted by the parental education on the academic ability. Okay, so this is R square value. So this is the model summary of your model. Then after this, you can see that is that whatever the model you are creating, is that significant model or it is non-significant model, right? So that you will do with this ANOVA table. So you can see that this is the F value and this is the your P value. So P value is very significant. So P value you can just see here 0.001, and this is the grade less than the 0.05. So it means that this model is significant. Now we will come on the coefficients. So this is the by coefficient value, and this is the your another coefficient value. Okay, so this you can create. Now you can create the your model.
Sir, can you explain that unstandardized and standardized coefficients?
Yeah, so once we will be having if it is we using this unstandardized method or standardized coefficient of beta, if this value is both value is coming to be this value is the smaller value. So in most of the time we will be taking the unstandardized value, and if it is this value is suppose is coming to be negative, then we will be going for standardized coefficient of the beta. So here also we can see that if this value is significant, so we can go for the unstandardized beta values. So that you can go for the 5.21. So here that
Sir,
you can
this
decide.
point is not clear. Please explain what is the criteria and what values will be right in the results part.
Yeah, so here three things you can take out from these three model summary, ANOVA, and the coefficients. Okay, so I will tell you one by one. So in the model summary, you just take out the R square value, means it will saying that how much the dependent variable is impacted by the independent variables. Okay, so that is 52.9%. And here it will tell you the overall significance of your model. So is that model is significant? If it is P value is significant, that means model is significant. And here these are the your A and B, alpha and beta. In the model, what is your model? Y is equals to A plus beta X. So what is the value of A? A's value is 0.79. What is the value of B? That is a 5.2.
A is negative, na sir?
That's a point minus 0.7, whatever is value. So this is your A value, and then B value is 5.2. Okay, so let me show you this in my here as well. So these are the some my questions for you. You can note down or you can just read it, these questions.
Sir, could you please explain what does F value mean in ANOVA?
Okay, so F value is going to be higher value. That means you will have a significance model, means significance p-value, you will be getting it. So f value is a ratio of the two chi-square variate. So here the whatever the f value you will get it, that will be a higher value. That means that higher chances of the significant p value. So that you will be doing here in the f ratio.
Sir, how much
Deepak,
manual, sir? Evening, sir. I would like to ask you that when we intend
You are not clear. You are not clear.
Hello,
sir,
sir.
I just want.
You
Hello.
just hold a minute. You can see all these things. Then after that, you can ask the question. I think it would be better if it is, maybe because I'm just trying you first phase of this regression. Then after that, I will tell you the second phase. Then after that, you can ask the questions.
Okay, okay.
So we will all the questions will be taken to the last of the session.
So first problem is that you can do it here. So develop a scatter plot to determine the relationship between the academic ability and then parental education. So that you can easily do. Go for the graph scatter, simple define, then y-axis and then x-axis. So this is your graph. So from this graph, you can just easily see that is this linearly associated or not associated. Okay. So this is your linear part is done. First assumption is done. Then you will go for regress the academic ability on the parental education and estimate the regression equations. So ultimately your goal is this one. So you just want to create this model and find out the value of A and B. Okay. So you already know the A and B value from the last sections. So you can just find out. So how we did it, this one, the regress these two variables. So you gone through the regression linear, then you will did this one, standardized, residual, standardized, and then continuous and okay. So after that, these are the output you got. So you will be using this R square value. Then you will be talking about this is the significant value. F value is 81. So this is the if this value is coming to be, it is a ratio of these two. And this is your significance p value. It means that you are getting the significance model. Then after that, you will go for the constant. And this is the parental education. This is the constant is 1.65. And this is your parental education. This is your A value, and this is your B value. So you can put here, and now your model is created. Okay, so this you can do it here from the whatever the data is with you, that you can do. So residuals you can just find out from the here. This is the residual table. So once you will click on the statistics and then go on the residual, then you will get it this one. Then after this, you can conduct an analysis of the residual produced by the regression equation. So you can go for the residual. You can see that what is the residual is coming out. So you can draw the histogram of the residuals. So how you can do the histograms? So you need to go for graph. Then you can go for this one. Then you can go for the histogram. Okay. So this is the way to go for the histogram. Then you will just talk about the standardized residual and this normal click. So you will get this is your standardized residuals. Now after that, you need to check the normal probability plot of the residuals. Okay, this you can go for the PP plots. So you can go for the PP plots. How you can go for the PP plots? So it will be this option is So you can go for the, I think I will tell you, it would be in regression only. So this is the your normal PP plot. So here you will be using the standardized residual, and then you will find out the normal PP plots. Then after that, you can go for the scatter of the standardized residual against the predictions, standardized predictions. So that you can do with the scatters, define the standardized residual and standardized predictions, so that you can do this one. And after that, you can easily find out, you can create this model, you can see that how much the variance is academic ability is accounted for the parental education. That you can do. So how in the next part, I will be again telling you, this is the linear. Then you will go for model fit, then R square, descriptive, that you can select. Then you can go for the plots, histogram and normal plot. This one, then you can save. So you can go for the you can talk about the residuals. Okay, so you can take the residuals, you can just click over here, so it will be saved in your data. Continue, then click on OK. So after this, you can see that this is your descriptive statistics of these two variables, dependent variable, independent variable. Then you will see the correlations between the academic ability and the parental educations. Then you use the enter method. Then after that, the model summary. So this is your R square that you can see. That is my important part for me. You need to understand what is your overall model. Is that significant? So earlier also it was significant. Then after that, you can find out this is your A value and this is your B. So these are the coefficients. And this is your residuals. Okay. So this is your residual value. And here this is your histogram of, and this is your PP plots. Okay. So this way you can do this all analysis. This is clear for all of you. So let me show you this data. Again, let's say if it is, I'm using the more than one independent variable. So let's say I'm using the parental educations, or I'm using the age as well. So really these two variables impacting your academic ability or not. Okay, in my data sets. So this is the, we will have more than two variables. So apart from that, there is one more thing. So this residual is coming up. You clicked on that save part. So this residual is coming up. Now you can see that is that residual is say the constant. You can go for the normality plot of this residuals. Okay. So now you can see that we will take for multiple regressions. Now we will go for the multiple regression. This is the linear. So the your dependent variable, independent variable. So I just want to use age and the parental education. So these are the two independent variables. So here we can go for the multiple regression. Okay. So again, we can go for the what statistics is with you, that you can select. You can go for the plots as well. You can go for the, you can save the residuals as well. Okay. Then click on OK. Now this is your output. So you can see that this is your descriptive statistics. Then you can see that correlation between your parental education and the age. Then you use the enter methods. Then here you can go for the R square. So R square is the 0.53, and the model is significant 0.002. It is less than the 0.05. Then after that, this is the your 0.2, and this is the 5.1, and this is the 0.042. So this is the basically now model is that academic ability is equals to A plus B multiplied with the parental education plus C multiplied with the age. So this is your model you would like to create. So you can take out these three values. So this is the coefficient value with respect to age. This is with respect to parental education, and this is your A value, intercept value. Okay. So this you can take out and then put it over there. And these are your residual value. And this is your histogram. And this is your PP plot. Okay. So this is your multiple regressions. Is that clear? So now you can get the answer of these all questions. So now you can just find out this one, or you can just also find out the A is equals to A plus B plus parental education. Okay, so this you can create for the multiple regression. So now this is clear for all of you. This what is the single regression or multiple regression, and how you can perform on the SPSS. So now you can ask the questions if you have.
Sir, thank you, sir. Sir, it is a very knowledgeable lecture, sir. And sir, I have a question how can we interpret the data of Durbin-Watson ratio as it is correlated with autocorrelation?
So if it is this Durbin-Watson value is coming to be more than 1, that means there is no autocorrelation is existing in your data.
More than 1 means no autocorrelation. Okay, sir. And sir, can we predict some mathematical equations of dependent and independent variable from that, like y equals to x plus b, like that?
No, but it's I'm telling here now. So basically, your purpose is that you would like to create your model. Means you would like to create your mathematical equation. So this is your equation. So you want to create that academic ability is impacted by the A plus B. So you just find out the A and B so that it can be further used for the your own purposes. So this you want to create. So this is a nothing but it is a kind of a mathematical equation.
And sir, the difference between R square and adjusted R square values?
So R square is basically it's how much your dependent variable is impacted by the R square. Once we will be adding the more variables or more independent variable, then how it is impacting your dependent variable. So this is your basically a adjusted R square.
Thank you, sir.
Sir, R square, if it is low, can there be a significant relationship? Because in sometimes what happens is the value of R square is not so high, but the P value shows the level of significance. So is that possible?
Yeah, actually, it can be possible. It's depend on the what discipline and what area you are working.
Okay.
Sometimes it is happening that the R square value is coming to be lower, and suppose that it's saying that the 0.15, so means that 15% is impacting your dependent variable.
Correct.
And
Huh,
parallelly, it's showing that your p value is also significant. So sometimes it can be happen, but you can just relate the things with your theory as well. Whatever your
Okay.
idea in that disciplines, what objective you captured, and you can relate with the theory.
Okay. So
So
we
that's
it's not always like, you know, the data is not true. Sometimes it might be possible.
yeah, it could be maybe some other reason would be there. Maybe you will be having a less data, or maybe some other points would be there. So in respective that area, you can create the interpretations.
Okay. Okay. Thank you, sir.
Hello, sir. I
Hello,
want
sir.
to know what is the significance of adjusted R square and how it is different from R square.
So just now I explained you about the R square and the adjusted R square.
Sir, I have one question. Sir, hello, sir.
Yes,
Am I
yes.
audible? Yes, sir. Many times what happen, we use regression analysis after adjusting for socio-demographic characteristic as our second objective. So in that case, what kind of like linear regression or what kind of regression should we use? Because in option, we also have generalized linear regression. So in my thesis, I have used that thing, but I'm still confused. What kind of linear? Suppose I have some quality of life scoring,
Okay.
and I have to check for age, gender, education, and occupation. So whether these socio-demographic characteristics are impacting my quality of life scoring or not. So in that case, what kind of regression, like what should I
So
do?
what is your dependent variable? The quality of life?
Score, yes, quality of life scores.
So if is that what kind of the score is the rating score?
Yes, sir, categorical scoring.
Categorical scoring. So you can go for the ordinal logistic regression.
Okay, and sir, it is also having continuous scoring also. Like in median the scoring is there, median plus minus standard deviation. So us case mein, sir, what should we do?
No. See, there is a two clear things. If it is the categorical data is there, then
Yes,
you
sir.
can go for the logistic and the ordinal logistic regression.
Yes, sir.
If it is continuous is there, then you will go for linear, multiple, and so many other methods would be there. According to the
yeah, so that's what that is my question. Suppose it is continuous data, my scoring is in mean plus minus standard deviation, and I have to.
What do you mean by this mean and standard deviations plus minus? What do you want to say this one?
Sir, continuous data. Quality of life scoring is in continuous data, and I have to adjust for socio-demographic characteristic.
Yeah.
Whether age is impacting or gender is impacting.
In general things, there are the two. If it is your continuous dependent variable is with you, then
Yes,
definitely you will go for the multiple regressions. Fine.
Yes,
But there is a more analysis would be there. If it is your dependent variable is what is the characteristics of the dependent variable. So I need to check it. It is a exponential distribution. It is the Poisson distributions. What is the distribution of my dependent variable? Accordingly, we can further say that you can go for this kind of the analysis. Before of that, I'm generally saying that you can go for the multiple regression.
Okay, sir. Thank you, sir.
So the R square value, can we also say that it is some sort of a correlation among the data?
Correlations here, you can say, as you are saying that you finding some relationship. Before of that, once you will see the R square value, then you will see the R value as well.
Yes, sir.
So that's also telling the same. Is there anything relationship between these two variable on?
Okay. So in SPSS output, there was one graph which was a graph in between predictor and the residual. Could you please explain it again? So like predictor is our data and the residual is after the calculation the same data, right?
Yeah. So once you will do this analysis, then in your data you will get that these two variable is coming up. Some new variable is coming to you. So this is the residual one when we will do a simple regression. Then when you did it, this one, this is the second residual. So if you want to save it, this residual, and later on you want to check it, so that you can do with the normal histogram, with the help of the histogram.